Hello guys, so in this tutorial video, we are going to look at how do we send the data from your local computer to cloud service, which is your AWS. And specifically in AWS, we are going to use AWS IoT Core services. There are three ways in order to interact with AWS services. One is AWS SDKs, software defined kits. Other one is your AWS CLI, command line interface. And the third way is what we are looking at currently is our management console, which is nothing but GUI or some kind of a graphic or management console. And you can see there are different services that is offered by AWS itself. Now you can see here you have compute, you have storage. Well, we can interact with all of these services for our use case, even if it is just IoT. So for example, we can send our data or try to test it in IoT Core, try to perform analytics using QuickSight, or run our broker on EC2 by installing or initiating the server itself, and then store our system. Or let's say if we have something called some single page website, we can just store that into S3 storage. And a lot of functionality mix and match you can do. You can perform Lambda functions. If something happens, perform this file or store it or whatever. With the help of rules, we can make things interactive. Let's say whatever you're sending the data on IoT Core, you can perform some kind of rules that stores into database, DynamoDB, or you can send the data over a static website being hosted on EC2 or LightSafe or some other dynamic websites. So let's get started, and I'm going to show you how to initiate or get started with IoT Core. So I'm going to go on the service tab and go click on IoT Core. It's going to take some time to load things. And on the left side, you can see there is a panel where you can just click on and the options will interact. And what I'm going to do is we are going to get started with manage and things. But before that, let me explain you some of the features of it. Whenever you try to interact with it, or if your connection is established, it will show you right here if your connection was established or successful. And it will show here if the message was published or not. It could be some other reason that you are not able to display the message. That we will explore in upcoming video. Now let's see, to get started with it, we will first choose our manage things. And here you can see I've already created one. And I'm just gonna put it here. And we start by creating it. Create a single thing, and you can name it something which is relevant to your application. So let's say my application is something like random data, and for clarity I'm going to use camel case notation. And not necessarily that you need to specify some kind of thing. You can just scroll down and skip all of these steps and click on next. Now in order to make things interactive, or in order to make things more secure, you need to add some digital certificates. Now discussing about a digital certificate is a part of another video which I'm going to publish later on, but you can understand it's something like a certification given by a authority which is also digital, or which is established authority that says, okay, you know what, these two guys who are trying to interact, which in our case is a client or some kind of program, and the AWS, they're all authorized to interchange or exchange the data. Now, how do we get started with it? Create a certificate. You can also upload your own, but it will take them time to learn that thing. But as of now, we can just create our own, which is created basically by AWS. Now, there are a few things you need to download. You not necessarily have to download a public key also. You only need to download a certificate for this thing. It's kind of a certificate given to us, or a program or a thing in your case, since it's IoT, Internet of Things. You can just download this part. It's just a certificate saying that, you know what, this device is secure to talk. And in order to make or use services, you need to have a private key, which has to be only with you. And you need to save it in a folder which is easily accessible, but you need to store it in a way which is not easily accessible for anyone else except you. And now the third thing we need to download is root certificate authority. Now this root certificate authority is the one authority that I was talking about. These are the people who gives the authority or make two device interact with each other. And the certificate that we are going to download is basically based on X509 digital certification. Now here I'm going to select this Amazon root CA, right click on it, save as, and you can save it as however you want. Let's try to create a desktop folder. Control Shift N. You can do that on your desktop, and we can just say AWS IoT test as a folder name. Go inside it, create another folder saying certificates. Now it's not necessary to create a certificate folder, but it just give you a good folder hierarchy where you can easily locate things just for your convenience. Select here and then you can save it here. Now everything is saved. All I'm going to do is go back and activate this part of it. Now everything is done. Certificate is created. Go and click on attach policy. Now we haven't yet created a policy already, although you see that there is a policy created over here. What I'm going to do is, since you don't know how to create the policy, I'm going to just register a thing, and later we will be attaching the policy to this thing. Now policy means what do you want this thing to do? Do you want it to subscribe? Do you want it to publish the data only? You want it to do everything else? So to do that, we will go to secure policies and click here, create one. Give a suitable name, let's say a random data policy. And go down below. It says, what do you want this thing to do? I want it to do everything, publish, subscribe, and whatever it is. And you can select this colon and asterisks. Here, what you can do is, instead of all of this, I don't want to do, let's say, very specific thing. All I'm going to do is just put that into a asterisk saying you perform everything. Now I'm going to say allow and create. Having done that, what you need to do is just go to this random data policy, go to certificates, and it says that you don't have any certificate yet. And this is the description of whatever you have done. So this is what the whole statement of policy looks like. You can do the same thing with the help of Amazon AWS CLI, but we're going to go back to this thing and try to attach a policy to it. Now this random data doesn't have any policy. Go to security tab, actions, or click on this security and attach policy. The policy that we have created just now is random data policy. Attach with it. Now everything is done. In order to test it up, you can go to test and see if the data is being published or not. Now, before doing this, we need to write our own program in order to send the data over here. Now, if you remember, we have already downloaded the certificate. All we need to do is now write a publisher program which publishes a message over to this specific topic with the help of this digital certificates. Now here we are going to write a program for interacting with AWS. We are going to use a PAHO MQTT client, MQTT library, in order to realize this part of a MQTT program. We start by importing PAHO MQTT library as, let's say, publisher, or let's say MQTT, and create an object saying, let's say, publisher MQTT.capital client. We are not going to provide the name of the client as of now, or I'm going to fill up the details later on. So I'm just going to leave this as it is. The next part of the publisher program is publish. Now, since we have created the object here, we need to connect to a broker and followed by port. Now here we are going to use secure port 8883. I'm going to speak about what is that. Now that we have created an object of pub, we need to connect it to a broker, which you already know of. So I'm going to write just the broker and then port here. And I'll be defining all the variables over here now. And let us just remove all of them and replace it with variable names. And I'll be doing that and defining them over here. So broker, and then you have port. After you have connected, we are going to publish a message saying publish, and the topic name, let's keep it as AWS IoT / first try. Keep it unique. If you keep it something general, it will just maybe a lot of people might be trying to send the data, but let's keep it unique as possible. And we are going to send a data called hi, or we can just create a random number and then try to send the random data. And here we are going to put QoS equals to 1, quality of service. Before this, since we are trying to send a data over secure port, we need to add a TLS set, which is transport layer security, and configure this program for that. So TLS _ set. This first parameter is going to be the certificate of certification authority. Second parameter will be the certificate of the client itself, the device, our device basically. And the third parameter will be the key itself. And after that, you will see that it will just try to send a random data, which is our hi in this case. Now, how do we find out this client ID over here? Let me just take you back to the where we are going to test it. Let's go to this part, AWS IoT. Here you can see your client ID is this part. Just copy this part and go back to your program. And paste it over here. The broker is basically the endpoint of AWS, which you can find over at the right side. So I'm going to click on, let's say here, view endpoint, and copy this whole string. And then go back to our program, put that into double quotes, and here. So the third thing we have is the port, which is our 8883. Now you can visit a website called oasis.org. This is the organization that is maintaining the standards required for MQTT. According to them, 8883 is a secure port, while 1883 is insecure port. For testing purpose, it's good to go with the 1883, which is just to test basic functionality. And since it's insecure, anyone can just hamper your data and whatever it is. So you better watch all of those steps. Now, the third thing is we need to set the path for TLS set. So the path for our TLS set is basically where we have saved our file, which is in this folder. Certificate. And what happens is, if you're not trying to, if one of your file is in another folder while this file is in another folder, then you need to provide the full path. Since my file, that Python file, I'll be saving it in this folder, I don't need to provide the whole C path. Rather, what I'll do is I'll just go into the certificate and whatever the path it is. So all I have to do is just copy this whole thing and put it into my program. Now this is not just it. What I have to do is I have to change the extension of this thing, the Amazon certificate file, so it behaves like it's a certificate, which I'll do after I have added all the attributes here. So put that into double quotes. And second thing is the certificate of the thing. Go back to this, and this is your certificate. Copy this up, go back to your program, double quotes, and paste the path. Now the third thing is the key, which is your private key. And copy this path and go back to your program and try to save that. Now since you have seen, I went to the folder called certificates, so I need to add that over here. Certificates / copy this up, paste. And the next thing that I promised was that I need to replace the extensions of it. So I'm going to go back to certificate now and replace its extension to CRT, which is a certificate, while also replacing this into just PEM, which is encoding method, and over this also to PEM. Go back to your program and do the same over here. This is just CRT certificate, while this is just your PEM, while this is going to be your PEM. That's it. I'm going to save that into the certificate folder now, which is in my desktop, AWS IoT test, and here I'm going to save it as AWS IoT test program. So you can see the path of my folder is now desktop, this and this part. Now AWS IoT test _ test / certificate is where all my certificates are present. All I have to do is just run this program and check if my program is running well or not. Before that, let's have a quick check if everything is written well. So our client ID is correct. Our broker, the endpoint is correct. Okay, the port number is correct. Client is correct. Our Dls Set is fine. Broker, publish, and that's it. Now I'm going to go back to AWS IoT and here subscribe to a topic called, let me just go back and check topic name, which is copy here, go back and put it over here. You can select the QS1, it's recommended, and then subscribe to this topic. Now all I need to do is just run the program and you will see the message being run. So run and run module. You can see that there was no error, so the Python program just ran, and then it showed the output. Let's see if in our IoT test online the message was published or not. So there is one good reason that your program might not work is because one of the few changes that I've done is make sure whatever certificate that you have got, instead of having this hyphen sign like that, replace that with _ and same goes for over here. What I did was I replaced this type of file that I already have with _ and you have to do that necessary changes in your certificate file also. The next thing what I've done is just replace the topic without the topic separation. Don't make some common names. So for example, the previous broker name or the topic name that I was using was AWS IoT. Instead of that, I have used just AWS IoT _ test. Possibly that there is some reserved topics that you are not allowed to use. Now, if I just run this hello and F5 and the data is being sent, I'm going to see that in my AWS IoT Core if there is any hi message sent or not. So you can see right here 18:41, it's the exact same time, and you can see the message is being sent over here. I hope you like this video. Keep sharing this video if you like it, and if there is anything that you want me to cover up, let me know in the comments below. Until then, keep learning. Bye bye.